So our next storm that we're going to talk about are hurricanes. And I know that you know what a hurricane is. You can visualize it. You've seen them on the news. You recognize this picture, but let's define what it means to actually be a hurricane. First of all, hurricanes are low pressure systems. They form in the tropics near the equator, and they have very strong thunderstorms, and they must have winds greater than 73 miles per hour in order to be classified as a hurricane. Now, in other parts of the world, they get hurricanes, but they have different words for them. They will call them typhoons or cyclones, especially in the Indian or in the Western Pacific Ocean near Asia. Now let's talk about this word hurricane and the origin of the word. Where does this name come from? It actually comes from the Central American culture of the Mayan people, which is kind of odd because we don't have any words in our language that come from Mayan. Well, here's why. In that culture, in that part of the world where hurricanes were very common, they had a name for them. Like a lot of ancient cultures, you assigned a deity or a god to certain events that you would witness. A sun god, a rain god, a storm god. In this case, a hurricane was the deity or the god that was associated with these crazy big storms that we now call hurricanes. Now, this is unusual for us because most of our vocabulary comes from Latin or Greek, Old English, German, whatever. They come from European-based languages. Well, why is there no European word? Because hurricanes don't tend to happen in Europe. So in Europe, there was no need for a word to describe this storm that they never saw. So when the early settlers came to the Americas and they said, "Whoa, wait a minute, what's this crazy storm?" And they started asking local people, they referenced this god Hurricane, which then evolved into the word that we now use, hurricane, for these types of storms. Now, hurricanes just don't pop up out of nowhere. There are some steps that hurricanes have to go through in order to form. First of all, you have to have this phenomenon called a tropical wave. This is where you get the low pressure, because remember, hurricanes are low pressure, and that low pressure got to come from somewhere. They generally start off the west coast of Africa. And then, because the trade winds are moving towards the Americas along the equator, you push that low pressure along the equator, along the trade winds, and it can eventually strengthen. It can become a tropical depression when we start to get some storms developing. Start to get a little bit of winds, 23 to 39 miles an hour, and a tropical wave doesn't always form a tropical depression. And a tropical depression doesn't always lead to the formation of a hurricane. But in order to have a hurricane, you have to go through these steps. The next step is what we call a tropical storm. This is when the storms get a little bit more organized. They start to rotate fairly well, and they have sustained winds of 39 to 73 miles per hour. So they're getting close to that threshold of when we can start to call a storm a hurricane. Now, in order for all this to happen, there has to be a set of ingredients that have to be true. First of all, hurricanes are storms, which are clouds, which need water evaporating to form. And we know that warm water evaporates better than cold. So the first thing you got to have for a hurricane is you got to have a nice warm water source so the water will evaporate and make the storms. You also need that low pressure because remember, the warm water wants to evaporate, but if there's high pressure pushing down the water, it won't. So you need the low pressure that's going to allow that water and air to rise in the sky to form clouds. Doesn't matter how warm the water is, if you have high pressure, the water is going to stay down and you're not going to get that rising effect that's going to give you the clouds and hence the thunderstorms that will make a hurricane. You also need this. You need the upper level winds to not be so crazy because if the winds up here get to be so strong, if these winds up here are blowing really strong, they're going to keep clouds from forming. And without clouds forming, we don't get those storms. So we got to have the jet stream to be kind of chill. We got to have low amounts of wind shear or crazy upper level winds that will allow those clouds to form and then make bigger storms. So here is the perfect situation that will allow us to have a hurricane form. We got some warm water, low pressure, and very low level upper winds, especially an absence of the jet stream. So in a nutshell, here's what we got to have. We got to have warm water and we got to have low pressure. And we've got to have calm upper level winds that allows those storm clouds to grow big enough to make those big nasty storms where you get the high winds and hence a hurricane. So where do you have all these key ingredients? In a word, it happens in the tropics because we know that this is where the hot water is. This also is the case where we tend to have those low pressures because we know that the hot air is evaporating, so we tend to get low pressures. The final aspect is our friend the jet stream. Think about the jet stream. He doesn't tend to dip down into that tropical region. So the absence of the jet stream helps give us the wind situation that will allow these hurricanes to form. Now, here's the stage. Here's how this goes. Over here in Africa, we've got some nice, hot African desert. So the air is getting hot, there's no water, and it rises and it tends to make low pressures. Well, if that low pressure ends up coming out here over the ocean, which it can because remember the earth is spinning, that's where my hurricane is going to begin. That's the start of my low pressure. Well, then the trade winds are going to blow that low pressure across the tropics. And remember that water is warm, so my my storm can then start to grow and eventually can grow into that hurricane. Especially once the storm gets over here, because we know that's where the waters are warmest and gives us the best set of ingredients to make a hurricane. Now, when does hurricane season happen? As opposed to tornadoes, which can happen pretty much any time of the year, although they're more common in spring and into early summer, hurricanes very definitely have a season, and it's from June 1st to November 30th. So we just ended hurricane season. Well, why are those dates important? Because that's when the ocean water is warm enough in our hemisphere to make enough evaporation that will develop into a nasty enough storm that will eventually morph into a hurricane. The most active months, just like tornadoes have a months or time of the year where they're more active, hurricanes tend to be greatest and strongest in August and September. And that's later in summer because it's taken that long for the water to get that hot. That's when water is at its hottest, so that's when hurricanes are a lot more likely to form. Now, you notice from this graphic over here, it's not impossible to have a hurricane out of season. You can see that January to April here, well, we've had 5 recorded hurricanes from 1851 to 2050. It's not a lot, but it's not impossible. You do notice that these months here have by far the most occurrences of hurricanes. And once again, that's when the water is the warmest. Now, where do hurricanes not form? Well, if you got cold water, you lose that first key ingredient. So the more northern you are in your latitude, the less likely you're going to have a hurricane. This is why California doesn't get hurricanes, because remember that ocean current off of California is a cold water current, and hurricanes need warm water. So any place where the water is cold, you're not going to likely have a hurricane develop. Once again, it's not impossible. Here is a Eastern Pacific hurricane. On this coast of the Pacific, the water tends to be a little bit cooler. You can get a hurricane. Now notice it's not California. It's kind of down here south. It's Baja California, Mexico. You can have them, but up here, generally the water is way too cold to have a hurricane form. So, in a nutshell, you see this, not too many hurricanes out here because we know the Pacific stays cold, especially our side of the Pacific. Up here, tends to be too cool. We've got that Labrador current coming down of colder water. But we do know the Gulf of Mexico is a nice big bucket of evaporating hot water. So that's hurricane central is the Gulf of Mexico. Now, how big are these things? Well, a small hurricane, 140 miles. That seems pretty big until we note that hurricanes can be up to 700 miles across. Really big. We're talking about the size of a state. This is Hurricane Andrew in 92, and there's a kind of an enhanced satellite image, a graphic, and you can see it is the size of the entire state of Florida. So when we describe the size of a hurricane, we're going to use this word big, like state-sized big. Now, how long do these last? Most hurricanes, a week or two, because it takes a while for the storm to grow to that size. The world record one was 33 days. And once again, that's a world record. So, never more than about a month, because after about a month, the hurricane's going to go somewhere or it's going to die out. They do tend to last longer in the Pacific. And I'm talking about the Pacific, not California. I'm talking about the other side of the Pacific, Asia, and in the Indian Ocean, because those oceans are bigger, have a little bit more of an equatorial water area. The hurricanes there can last longer and bounce around longer. Now, how fast do these things move? They're not very fast, 10 to 20 miles per hour. Now, this is very different than a thunderstorm. Remember, thunderstorms, man, they can pop up real quick. Tornadoes can happen almost instantly. Hurricane, not going to sneak up on anyone. We know when it's coming. It's big and slow moving. We can predict it. We can watch it. We can study it. Now, you should realize that hurricanes have this very unique kind of swirly shape. The question is, why? We haven't addressed this with any other storms like thunderstorms, even though we know that tornadoes spin. Why do hurricanes over a wide area have this spinny shape? It has to do with the Coriolis effect. Well, okay, what is the Coriolis effect? The Coriolis effect is the changing of the path of a fluid. So this can be wind or water. We already referenced this, although we didn't give it this name. The Earth is spinning. Well, water and air is not stuck to the Earth. It sloshes around. So as the Earth spins, the water and the air gets kind of sloshed around, and it doesn't move in a straight line. It tends to move in a circle, and in the northern hemisphere, it gets displaced or sloshed that way. In the southern hemisphere, it gets sloshed that way. That means hurricanes spin the opposite direction in the northern hemisphere as they do in the southern hemisphere. In the northern hemisphere, our hurricanes spin counterclockwise. And you can see from this shape, that's generally how we draw the shape of a hurricane. But in the southern hemisphere, they actually spin the opposite direction. Now let's talk about deaths and destruction. We think about hurricanes as being wind events, but in reality, most of the damage and most of the people killed in hurricanes are from water, not by wind. Let's look at why. We have this concept of what's called a storm surge. We know that winds cause waves. That's what waves are made of. So when winds push the water, the top layer of the water across the ocean and piles up and it makes waves. Well, hurricanes are really strong, really big, really wide wind events. Well, the wind can pile up the water so high that when the hurricane hits land, all of that water gets pushed onto land. This is what's called the storm surge. And obviously, the stronger the winds, the larger the surge of water. And we had this concept of high and low tide. If you've been to the beach, the water comes in and then it goes out. Well, if a hurricane comes ashore at high tide when the water is already high, the storm surge can be a lot more damaging. It looks something like this. Here's my normal high tide, and there's my average sea level. If my hurricane comes ashore, especially at high tide, it can do something like this. It can push water pretty far inland, a lot further inland than we would normally expect, even with a high tide. Well, people build houses and they roads and they live in these areas, and that means that their houses and their businesses and where they live can then be underwater from the storm surge, and that's what causes damage. That's what kills people in hurricanes. So, okay, how much water are we talking about with this storm surge? Well, to give you an interesting graphic, this was an 18-foot high wall of water that came ashore with Hurricane Ike on a peninsula or barrier island in Texas. Think about 18-foot tall wall of water coming ashore. It's going to mow down and knock down pretty much everything in its path because water is exceptionally powerful. Well, hurricanes also have this other unique feature called an eye. And the eye is the center of the storm. And it is, ironically, a calm part of the storm. And you'll notice you can see there doesn't appear to be many clouds there in the center of that storm. And that's because all of the air is rushing towards the center. We know it's a low pressure system. So all the air is trying to get to that central point, but the air never gets there. Because of the Coriolis effect that starts swirling my air that is trying to rush to that center of low pressure actually never gets there. It swirls around that center point and goes up before it actually makes that center of low pressure. This is what the eye of a hurricane could look like. Has very low clouds, has very low amounts of wind, because you can see right here around the center of the eye, the air is being forced up and it's swirling around, but right there in the eye, there tends to be a patch of clear skies and calm winds because the wind doesn't actually ever get there. Now, around here, we can see there's a bunch of air that wound up there with water in it. Well, what happens now is that air actually starts to sink back down because the storm piles up so much air around the eye. It gets to be a really, really tall column of air. Well, in the center is low pressure. So over here, I've got a lot of air. And basically what it does, it falls into the eye. Well, as the air falls into the eye, it heats up because it's coming lower in elevation, and that heating up of the air will inhibit cloud formation. It makes any water in that center evaporate. So this is why hurricanes tend to have a clear spot in their center, and that's why the eye is a clear center of very low winds and almost no precipitation. Now, the eye wall, on the other hand, that's the area right here, like right around the eye, and that's where it is nastiest because that's where all of the air is trying to rush to. Think about a slice of pie, and all the air in here is trying to get to that one point. All the air is trying to get to that one point. So right around the edge of the eye, you have an incredibly large amount of air trying to rush in to that center of low pressure. Well, that creates really strong winds. And that's what's dangerous about the eye wall. It is where the winds are fiercest and strongest and will cause the most damage and create the highest storm surge. Well, landfall. Landfall is where does that eye come onto land? And it's very important to know where the landfall is going to be. It's one of the things that we really want to predict about a hurricane is where is it going to come ashore? Because that's where people live. And let's look at why the exact location is important. So we get this idea that hurricanes spin like this. So here is my eye. So everything is spinning around the eye. If you're on the right-hand side of the eye, if you're in this zone right here, well, you can see you're getting the most water pushed onto your land. You're having the worst storm surge, which means you're going to have the worst damage. If we look over here, because of how the winds swirl, this is actually pushing water offshore. So in this area here, you're not going to have nearly as much storm surge, which means you're going to have a lot less damage. Well, that's why we want to know where the eye wall is going to be. Because if I live over here, I got to be very, very concerned about, hey, I'm going to have a lot of storm surge. I live on this side of the eye, I'm not getting it as bad. This is why we want to know where that eye comes ashore. Now, are these people over here in the path of the hurricane? Sure. But it's not nearly as severe on the left side, if you will, of the eye as it is on the right. Think about this situation here. This is one of the last hurricanes that hit Georgia. It was Hurricane David in 1979. Came ashore right here. And Savannah got it pretty bad because they were immediately to the right of the eye. So they were getting hit with really bad storm surge. Brunswick down here didn't get it nearly as bad because the winds were blowing offshore rather than onshore, so they didn't get storm surge as bad, hence didn't have nearly as much damage. So here we got a hurricane, and we said world record 33 days. Well, why does a hurricane stop? Well, remember the fuel. They need warm water. And if the warm water is cut off, then hurricanes die. So factors that break up hurricanes. Cold waters. If a hurricane moves from warm water onto cold water, well, it cuts off its gas and it runs out of fuel and it basically will stop. If a hurricane hits land, it's the same concept. Once a hurricane moves over land, it's not over water. It doesn't have water to pick up and fuel the storm, so it is going to weaken and it is going to stop. Sometimes hurricanes die over the ocean because you'll get a change in winds. And if you have that change in winds, that wind shear, it can tear apart the clouds and disrupts the flow of air, and that will stop the storm, because remember, these hurricanes are big storm events. So where do hurricanes strike? They are primarily East Coast and Gulf of Mexico here in the United States, but they don't hit every place the same. You do notice over here, yeah, not too much of a hurricane concern on the west coast of the United States. Florida is by far the top hurricane state. I mean, look at these numbers. I mean, Florida, and it makes sense. Florida's sticking out into that nice warm waters of the Caribbean and Gulf of Mexico. They're going to get hit the worst. But if we look up and down the eastern seaboard, look at North Carolina here, 118. But look at the states immediately to either side. Seems like a big drop between Virginia right next door at 59 and South Carolina with 74. Have roughly about the same amount of coastline. Why so many more hurricanes happening in North Carolina than in its neighbors? And this can be explained by something we have already learned about this semester, and that's the Gulf Stream. If you'll notice this Gulf Stream, and look how our coast here is kind of angled. Well, the Gulf Stream doesn't come and hug the coast so much. It's a little bit offshore. Well, hurricanes love riding that nice warm water of the Gulf Stream. And you'll notice North Carolina kind of sticks out and meets the Gulf Stream. It's right in the path of the Gulf Stream. Matter of fact, the Gulf Stream turns because it hits North Carolina. So that means North Carolina is going to get hit by a lot of hurricanes. The coastal areas up here, not so much, because my Gulf Stream is going to tend to carry my hurricane this way, and I've got this cold water current, the Labrador current that comes down the eastern seaboard, that will kill hurricanes before they tend to strike land in that part of the country. Let's talk about risk, and we've already talked about this concept, but the risk is basically an assessment as a how much damage or how much danger are you in from a hurricane. Insurance companies do a risk assessment when they figure out how much insurance am I going to charge you, because I need to know what's my expected loss from damage from hurricane. What kind of check am I going to have to cut? And you'll notice, no surprises, South Florida has by far the highest risk from hurricanes. They have a 1 in 4 chance. This was for 2024. They were about a 1 in 4 chance that they were going to get hit by a hurricane. And that's just 1 year. So there's an exceptionally high risk from hurricane damage in places along the Gulf Coast, especially Florida, and up the eastern seaboard. You'll notice it gets less as you go farther north. It's not impossible to get damage from a hurricane in Long Island and New York, but it's a lot more likely to happen in Florida. Now let's talk about hurricanes in the Gulf of Mexico. Hurricanes in the Gulf of Mexico are bad news. They are especially dangerous, and we watch hurricanes to see, remember that they're coming this way across the trade winds, and we're very concerned if hurricanes start tracking in this direction. And there's 2 reasons. One, we know that this water is hot. It's steaming hot. And what do hurricanes love to run on? Hot water. So if we get that tropical wave, that tropical storm, and it makes it into the Gulf of Mexico, it tends to blow up into a hurricane very easily. A small hurricane turns into a really big hurricane. It's like a turbocharger for the storm. The other reason why Gulf hurricanes are bad is there's no way out. A hurricane that gets in the Gulf of Mexico is going to come ashore somewhere. It's going to hit somebody. And that's what makes them especially dangerous. A hurricane out here, maybe not. Maybe it just kind of pokes around out there in the ocean and goes off to die in the middle of the Atlantic. But a hurricane that gets into the Gulf of Mexico is going to cause somebody some problems. A hurricane that does this, like I said, No big worry, because we know that the Gulf Stream is going to go this way. So even if my hurricane picks up that Gulf Stream and remains a strong storm, what's out here? Nothing. And by the time it gets to Europe, the waters are too cold and the hurricane will die. Now, the Bermuda High is one of our big driving forces here with predicting what our hurricane's going to do. You know what a high pressure is? High pressure is a cooler air, sinking air, high pressure air. And that's because out there over Bermuda, it's a pretty good patch of pretty deep water. Keeps the air above that water fairly cool, air sinks, nice high pressure. And high pressure will push out, as opposed to a low pressure where the air is rushing in. So we get this high pressure out there hanging out around Bermuda. That's why it's called the Bermuda High. Well, what does this mean for hurricanes? If the Bermuda High is pretty small and high pressures rotate counterclockwise as opposed to low pressures, they're spinning like this. And here comes my hurricane. My hurricane is coming along this way, and the high pressure system grabs it and it's going to fling it that way, which is great. It flings it into the north, away from land, over colder waters, where the hurricane doesn't cause anybody any problems. Great. However, the Bermuda High can also grow big. It can also move south. And you'll see in a situation like this, it can grab a hurricane and spin it right into the Gulf of Mexico. And remember, hurricanes that get directed into the Gulf of Mexico are bad news because they're going to blow up and they're going to hit some land and cause somebody a problem. So we watch that Bermuda High. If it's this big, not too much of a problem. Or if it's over here, good. But if it gets bigger or further south, that's going to tend to indicate that hurricanes can get thrown into the Gulf of Mexico and cause real problems. Now, we do rate and describe hurricanes just like we did with tornadoes. They're classified by how strong they are. This allows us to predict the damage and the danger that that storm causes us. The scale is called the Saffir-Simpson scale. And it looks something like this. There are 5 categories, categories 1 through 5, and the categories represent 2 things. They represent the wind speed. Remember, got to be 74 miles an hour or greater than 73 to be a hurricane. So a category 1 is the lowest level of winds up to a category 5, which is 155 miles an hour or greater. But remember, those winds also cause that very damaging storm surge. So the Saffir-Simpson scale also categorizes hurricanes by how high the storm surge will be, and that directly corresponds to how strong the winds are. Using this scale, we can then predict, well, what kind of damage can we expect? If it's a category 1 hurricane, I'm not really that worried, even if I live on the coast. There's no real structural damage. It's not going to kill me, maybe some flooding. But if we know the wind speeds are over 155 miles an hour, we know it can be an 18, 20, 25 foot high of water, and I can't survive that in my house if I live in the storm surge zone. Now, unlike tornadoes, where we go out the next day and we see, hey, what was the damage? What was the rating of this tornado? Hurricanes can be studied. We can measure them because they're slow and they're big. We know where they are. And as they approach us, we can take measurements. There's actually a group run by the government called the Hurricane Hunters, and they fly these planes with all these instruments, and they'll drop these little buoys, these little weather parachutes, collect some data from the hurricane. We know what the wind speeds are, so therefore we can predict the storm surge. We also measure the pressure because a lowering of the pressure means the storm is going to blow up. If the pressure seems to be increasing, we know it's dying down. So unlike tornadoes, we can predict hurricanes. And there's 2 groups. The Air Force has a group that monitors hurricanes, and the National Oceanic Atmospheric Administration, NOAA, also runs a group where they have 3 to 5 planes, I believe, that they will fly through the hurricanes and actually physically take measurements from the plane. So that's the end of the presentation. See me at this time to earn your done stamp.